So moments and centers of mass. So the big idea where we'll get to is we're going to find a shape, right? We're going to have some kind of a shape, and we're going to find the place in the where we would call the center of the whole plate, the mass that will balance it, right? That balances it in all directions. Okay, so let's just start thinking about two people on a balance, like a seesaw. So if I have this here, I could have a heavier person here and a lighter person here, and then that would balance them, right? So then it would be the mass times the distance would equal the mass times the distance. So this small mass times this larger distance would equal this larger mass times this smaller distance. All right, so if I call this x bar, then mass 1 would be x bar minus this distance x1. And then if I call this mass m, mass 2, and just to keep the distances the same, I'd say this distance x2, go all the way out to x2 here, and subtract off this x bar. And then multiplying and solving for the x bar, what does it turn out to be? The mass 1 times the distance x1 plus the mass 2 times the distance x2 divided by the total sum of the masses. So that's what gives you the middle, or the sum of the masses. Okay, so that's called the moments. And the moments are the masses. So in general, so what I'm going to do to find the x bar is I'm going to add up the sum of the moment, or the masses times the x's, and divide by the total m, which is the total mass of the system. So that's called the center of mass. So that's x bar, y bar. And if we're just talking little masses, 3, 4, and 8 at these xy points, right, then to find the mass, the center of mass, I'm sorry, this is the moment. The moment with respect to the y-axis, or about the y-axis, I'm going to take the mass of 3, and then I'm going to take the distance that it is away from the y-axis, which is the x. And so the m sub y, or I'm sorry, the next mass, the 4, would be times the distance it is from the x-axis, which would be the distance it is from the y-axis, so that would be 2. And then the mass of 8, the distance it is from the y-axis, so that would be the x distance of 3. Okay, so then to find the moment about the x-axis, then that's going to be the mass times the distance it is from the x-axis, which is the y value. And the next mass of 4 times the negative 1, and then the next mass of 8 times the distance of 2. So we add these up. So these are the moments. And then to find the center of mass, we take the moments and we divide it by the total mass. So this is the center of mass, or commonly called x bar, comma, y bar. All right. So that's just when we have little masses and little xy points. Okay, so now when we're talking about the region under a function, right? So we're going to have under a function here. So this kind of enclosed this area here. We want to find the center of mass. Okay, so first we're going to want to find out what the total mass of this thing is. So the total mass would be the total area, right? So the total area, which would be the little m, right? The total area. And I'm going to keep it in general that we're always talking about a uniform density kind of material, and it's always the same. All right, so the moment of the region about the y-axis will be the distance it is from the y-axis, so that's going to be an x value. So the x value times the area under the curve. So that gives us the moment about the y-axis. The moment about the x-axis is going to be halfway up. So let me just draw it again so I can kind of get an idea. So we want to go halfway up to get to here, and then multiply or halfway up the function. So 1/2 of the y value, 1/2 of the y value, that's this, times the mass, and so then I get 1/2 f of x squared. So these are the nifty formulas you'll just need to know or use. Okay, so to find the centroid, we're going to take the x bar. To find the x bar, we take the moment and divide it by the mass. The moment and divide it by the mass. So lots of work to be done. Okay, so first, anytime you do these, I want you to draw it to get a sense of what's going on, because many times you'll see that one of them is going to be, or something is going to be quite easy, straightforward. So if I want to find the center of this region, so you know this is a half circle of radius r. So here we are, r to negative r, right? And then above the x-axis, so this is the region. So we're looking for the center point, right? So looks like it would be right there, doesn't it? Yes, right there, somewhere up. And I don't know what the height would be, but I know since this is negative r and that's r, that's going to be at the x value of 0, correct? So I can see that the x bar is going to be 0. I do not have to do computations for this. And so to find the mass, that's the area under the curve, right? So it, whoops, I'm not 0, but it would be negative r to r of this. But we are always thinking, right? So this, I think, I could use the trig substitution if you choose to go there, but I'm thinking this is the area of half of a circle. So 1/2 pi radius squared, that's it. That's the area under this. So you would get that same thing, but with trig substitution, but let's not use trig substitution. Let's go find our y bar. So our y bar would be 1 over the mass, so there it is, and then integral from negative r to r, and then 1/2 f of x squared, squaring the radical, that makes it nice, so I just get to take the integral of r squared, that's a number, so that's r squared x, integral here, plug in the limits of integration, there it is.